Section 9.2, Part 2. Lesson objective: construct and interpret a confidence interval for a population mean. Lesson objective: suppose a simple random sample of size n is taken from a population with unknown mean mu and unknown standard deviation sigma. A 1 minus alpha times 100% confidence interval for mu is given by this formula. The lower bound is x bar minus t alpha over 2 times the sample standard deviation divided by the square root of n. The upper bound, upper limit of the confidence interval is x bar plus t alpha over 2 times s divided by the square root of n. The interval is exact when the population is normally distributed. It is approximately correct for non-normal population provided that n is large enough, and our rule of thumb is n is 30 or more. If the sample size is less than 30, then we have to check to see if the original population is normal by using the probability plot in Minitab or the QQ plot in StatCrunch. Let's do an example. The student body at many community colleges is considered a commuter population. The Student Activities Office at a certain college wishes to obtain an answer to the question, how far one way does the average community college student commute to college each day? A random sample of 300 community students from this college was identified, and the one-way distance each commuted was obtained. The resulting mean was 15.22 miles, and the standard deviation was 5.95 miles. Estimate the mean one-way distance by using a 95% confidence interval using the sample data. Interpret this interval. Our sample size is 300, so the central limit theorem kicks in. Our requirement is satisfied. So the next question we need to ask, is this going to be a t interval or a z interval? Well, because they talked about the sample and they said the resulting mean, and that means also the resulting standard deviation is coming from the sample. So this says standard deviation, but this is actually the sample standard deviation. So therefore we use a t interval. So from the problem we know that x bar is 15.22 and s is 5.95. Alpha is 5%, 0.05, because we're doing a 95% confidence interval. Our sample size was 300, so our degrees of freedom is 299. So using table 6, our t alpha divided by 2 is 1.984. The lower bound turns out to be 14.53. The upper bound turns out to be 15.90. The 95% confidence interval for the mean distance is 14.53 to 15.90. So let's interpret this confidence interval. We are 95% confident that the true population mean one-way distance to college commuted by a community college student at this college each day is between 14.53 and 15.90 miles. Let's do an example with raw data. Suppose a highway safety researcher is studying the design of a highway sign and is interested in the mean maximum distance at which drivers are able to read the sign. The maximum distances in feet at which n equals 16 drivers can read the signs are as follows. We have 16 distances. Construct and interpret the 99% confidence interval for the mean maximum distance a driver can read a sign. Well, the first thing that we have to check is, since n is 16, that's less than 30, we need to make sure that these distances come from a population that is normal. The way we check that is by using a QQ plot or probability plot. This is the probability plot for Minitab. We see all the points are within the bands, so this gives evidence that this data is coming from a population that is normally distributed. The next thing we have to decide, are we going to use a T or a Z? Since there was no mention of sigma, the population standard deviation, we'll have to take the data and compute S, the sample standard deviation. I will show you how to do this in video number 3. This is the statistics that Minitab computed. We see that the mean is 483.8 and standard deviation S is 89.4. Our alpha is 1%, 0.01. Degrees of freedom are 15. So T alpha divided by 2 from table 6 is 2.947. So using these values, we compute the lower limit to be 417.9. The upper limit, upper bound, is 549.7. Now you may want to pause this video and check to make sure that you can get these values. So let's interpret this confidence interval. We are 99% confident that the true population mean maximum distance at which drivers are able to read the sign is between 417.9 and 549.7 feet. Do I use a Z distribution or a T? Following is a flow chart that will explain when can you use the Z and when do you use the T. Is the sample size greater than or equal to 30? If it's yes, is sigma known? If sigma is known, you use the Z distribution. If sigma is not known, you use the T distribution. If the sample size is less than 30, we have to check to see if the population is normal by using the probability plot or QQ plot. The graph is approximately linear and all the points are within the bands. We have to ask, is sigma known? If it's yes, you use the Z distribution. If it's no, you use the T distribution. What if the probability plot or the QQ plot is not satisfied? Then we can't use a Z or a T. To use the Z, the normal distribution, sigma must be known and the original population must be normally distributed, or the sample size has to be greater than or equal to 30. To use the T distribution, sigma is unknown and the original population is normal, or the sample size is greater than or equal to 30. A non-parametric method, which is beyond the scope of this class, can be used when the population is not normal and when n is less than 30. Thanks for watching.